Okay, here we go. Again, 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 again. I need to have. It would be cool to have like some little background elevator music or something in here. Set the vibe. We are on our next topic, which is new data from the New Horizons telescope, which is looking at something called the cosmic optical background, which I think is very important to define what exactly that is, because it's different than the cosmic microwave background. We're just going to go through this real quick. Measuring the cosmic optical background is more challenging because it requires separating the faint background light from brighter foreground sources. So you have to like filter out everything. And what we're trying to do with that is just see the deepest darkest depths that are at the farthest ends of the universe. The CMB is so the cosmic optical background is like all of the light produced from everything that kind of leaks out into the universe. I mean, you think about it, light's constantly being created. It's moving at the speed of light, and the cosmic microwave background is the literal faint radiation left over from the Big Bang itself. So, we got a chatter. Hello, Mashin from Pakistan. Thank you for joining us in this journey to figure out how dark the universe really is. Okay, so we're starting off hard. We obtained special images to measure the cosmic optical background. Survey comprises 16 blah blah. Isolating the COB contribution to the raw total sky levels. Okay. The rest. Okay, so the estimated integrated intensity from the background galaxies that like just give off light is measured in this, but then the rest of the COB isn't zero. And the simplest interpretation is that the cosmic, like the faint light at the edge of the universe is completely due to galaxies. That's kind of a boring conclusion, but it's telling us how dark the very edge of the universe is. Let me ask this. Thank you, Motion. Yeah, I'm pushing pretty hard on this. This is the second stream today. We're gonna have another one at 6 Central Time with Ohm, the magical astrophysicist. So yeah, that's good. That's gonna be a really good one. I'm really looking forward to that one. Okay. So let's put the light at the edge of the universe in perspective instead of using fancy numbers. A night sky in a city can have a brightness of several tens to thousands of nanowatts per square meter per steradian, depending upon the level of light pollution. A natural dark sky, let's say you're in the desert, The sky brightness area comparatively at the edge. Okay. So the edge of the universe, the darkness there is about 20 to 30 times darker than the darkest skies visible on Earth. Even if you sum up all the light from all the distant galaxies and stars across the universe that have made their way there. Wow. This extreme darkness emphasizes how faint and so I guess the stars, I mean, they project light out there, but the thing is, the universe is so big and it's expanding so much that there's so many places for the light to go. Okay, this is going into the Big Bang, the cosmic microwave background radiation, which I brought up before. It's from the actual Big Bang itself. That's not what we're looking at. While our horizon encompasses almost 1 trillion galaxies that have formed over that time, they are terribly faint, and we need our most powerful telescopes to tally their presence directly. Jeez. I just saw this thing in Adobe that it just generates an image. I wonder what this will do. No, I'm not doing no more of that. Oh crap, I just realized you guys can't even see the paper. Jesus. I am retarded sometimes. It is the most remote camera. Okay. So we have this telescope out there, the New Horizons telescope. It's in the darkest place that we can feasibly put it. There it is. I have seen this in Space Engine. I've also rammed it into several planets just for the fun of it. What I'm kind of wondering here is that, like, shows that while the strong Zeo hormones are greatest, and like, is there something in here that is they're just saying like, okay, yeah, the present work is based on a program of new Lori images. Like we got some new data. Okay, methodology. Let's get some juicy stuff. Is this the actual light? The primary observation fields of the New Horizons. Okay. The map is not like a generalization as. Could this map be considered? You can measure the luminosity with a unit of lux. Sorry to be trite with that, but yeah. It will, yeah, it'll have a very, very low unit of luminosity, but I mean, when you get down to it, you want to kind of understand how low is it, like how far has the light created, um, what is the integration of all of the light that has ever been created by things in the universe, is kind of what we're looking at here. COB is expected to be isotropic, meaning that it should look roughly the same in all directions. That's a little bit boring. Yes, one cubic meter with only one photon inside is very, very low luminosity, but it is different than 2 photons. That doesn't mean that it doesn't hold a sort of like information. Okay, they're just showing how they did this. Also, if you just joined, James, the kind of the COB's brightness is this unit, nanowatts per meter squared. I don't know what the SR means. Imagine standing in a room illuminated by a single small candle from several kilometers away with a thick fog between you and the candle. You know the candle is there because it emits light, but that light would be so faint and diffused through the fog that you'd barely see it. I can take my shirt off, Tandem Cross. The cosmic optical background is like that candle. It's the accumulated light of countless distant galaxies, but it is spread thin across the vast expanse of space. So this is a good analogy as to how faint this thing is. That's very dystopian, Zach. So this is they're calibrating their little telescopes. These must be little fields. Oh, okay. So these are the fields that they were looking at. Like, I guess they aim their telescope around different places. So NHTF01, let's see what that looks like. NHTF01, more units. Amount of dust. Is there a key? There's no key. What's E? See, what I'm actually this. Okay, I'm actually really curious about this right now because I'm curious. There's a. Well, actually, James, when you get into the end times of the universe, um, I mean, photons, like everything decays, and then there's actually just like black holes swirling around everywhere. Um, and also you have theoretical things like uh, quantum flux, where particles are popping in and out of existence. Um, Also, we may even have made. I mean, in environments where we have to do experiments like the Large Hadron Collider, we have to isolate everything in there, so we don't disturb things. Yes, Zach. Actually, according to Roger Penrose's cyclic conformal cosmology, it does, and there's evidence in. Well, infinity scares me too. I'm curious what these values mean. Okay, what I'm gonna do is this. Okay, this is actually turning out to be a little bit interesting. What I'm going to do is take a picture of this and give this to ChatGPT, because I think that this magnitude of stuff is I want to know if like certain areas of the universe are darker than others, and it looks. I mean, there's variation between things here, so maybe this is actually true. Yes, trillions and trillions and trillions of years. I actually study. I'm Ohm and who's coming on tonight, and I actually really studied Roger Penrose's CCC theory, Zach, and I am gonna make a video about it. It's one of the coolest things in my opinion. Okay, EBV measures dust extinction. Let's just make that. Let's just put that there. Do you guys think if I had like cool chill or like a little music like in the background to set a vibe, that would be cool? Or no? I'm curious if we discover a highly efficient way of using thermodynamic free energy. Um, well, the universe has discovered a way of doing that. It's called stars. The thing is, the way stars work is they have so much mass, they're able to do something called quantum tunneling, which causes fusion to happen, and we can't do that because so we're trying to use like some fake methods. There is a way to blow up the sun apparently with a let's call it I guess a thermonuclear bomb, which is a video I'm going to make. Okay, this is what these values mean. I have not actually looked up the new Neptune theory. I don't know what that is. Okay, EBV measures dust extinction. HI column densities indicate the amount of neutral hydrogen gas. Okay, whatever. H, what is it? Omega. Ionized gas, dust temperatures. If IR intensity measures the far infrared light. Okay. CIB measurements provide insights into the diffuse infrared background from Okay. Okay, so I think this is like the actual light. Okay, it's a different wavelengths. However, I am going to write down that new Neptune theory thing, by the way. I like to collect mysteries. Thank you for that. Tandem cross. Okay, so this is measuring different fields show different variations in dust. Okay, whatever. I don't care about the dust. There's randomness here. So is there much variation in COB? Okay. CIB. Okay, so imagine like you get like because we're looking through dust and shit. Imagine that you have I could use ChatGPT tandem across, but I don't want to ruin this conversation with it at the moment. Imagine that you're looking through a bunch of dust, and that diffuses all the light, and so you have a bunch of clouds of dust, like cloud dust, galaxy here, and you're looking through all this dust, so the light's going to be scattered. COB uniformity. Huh. Okay, so right now is it's like 4:30 in the US, or it's like time that people are in traffic or whatever. And you usually get more people at night. Also, like since I'm researching something and I'm not just like regurgitating it to people, it doesn't seem to get like that many concurrent like viewers, although people do watch it like after I record this. And I'm gonna make a video from this too. The only way to get more concurrent viewers is to practice and to get better at this. Sky component level of intensities. Okay, this really is just measuring how dark space is. Literally. And here are all the images. Okay, here's a better one. Here's a better table. What does cis mean? The rand and cis. Yeah, so they're just looking at different. They're just looking up in the sky and seeing. Okay, it's like a little bit more here. A little. There's a little bit more light here and here. But there's. I do think that this might be. Eventually, we could get it to a level of accuracy as we do with the cosmic microwave background. And maybe discover some things from that. Oh, hey Josh, I remember, I remember you. Yeah, life has been pretty good. Been eating a lot of avocados and having to deal with girls here that try to rob me. Um, anyways, task good. There we go. Okay, the task is. So many statistical measures. Hello. So I think I'm gonna kind of just go to like ChatGPT here instead of wading through all of their statistical measures and their methodology. By the way, Josh, you should see the live stream we're having tonight at 6. It's going to be pretty cool with the astrophysicist, cosmologist, Ohm. Big shout out to that guy. You guys will. He has some. He knows some crazy shit. Okay, cool. Most true to know him back. This residual signal is not statistically significant from 0, meaning there is no strong evidence for additional unknown sources of light. Well, this is depressing. Sources of light beyond galaxies. So, I mean, that's cool. I guess there could have been light beyond galaxies, but apparently this paper shows that there wasn't. It's completely isotropic, meaning that it's the exact same everywhere. Where are my mysteries? My channel is called Strange Mysteries. I need mysteries in these papers. It's the stream with the guy comparable to Stephen Hawking, in my opinion. Yeah, I'm trying to get the streams better. I think when getting people on the stream is gonna help too. No, you didn't miss him. He's gonna be on in an hour and a half. Okay. So I'm going to. I think we kind of got as much as we can here. I'm going to cut this video and make a video out of it, and I'm uploading another video in about 5 minutes, and then we're going to have Ohm on, and think of questions you want to ask him. Like, you can ask him anything. Anything. He's basically God. Ohm. OEM. But, yeah. I will see you guys later. Thanks a lot for joining. And bye.